Hello, and thank you for your interest in this presentation despite the unconventional format. I'm presenting our abstract, which describes using a new sensor to measure bladder activity wirelessly and without catheters. The contents of this presentation do not represent the views of the U.S. government or the U.S. Department of Veterans Affairs. While humans tolerate urodynamics testing well, research in animals requires anesthesia or restraint and complex setups which do not mimic the physiology of natural bladder filling. This is especially problematic when studying the neurophysiological interaction between the bladder, peripheral nervous system, and dorsal root ganglia, particularly because anesthetics alter nervous system and bladder behavior. Our goal with this work was to develop a sensor to monitor bladder pressure and volume in the conscious, freely moving animal during natural bladder filling. Ultimately, this will yield insights to improve neuromodulation to treat incontinence in humans. Our previous work in submucosal bladder sensors has led us to a variety of devices to study bladder and bowel physiology in animals and humans. However, this talk will focus exclusively on our sensor to measure pressure and volume in the cat bladder wirelessly. The sensor uses wireless battery charging while implanted and transmits pressure and volume data in real time to a receiver worn by the animal. 3 electrodes are used to measure urine volume and urine concentration, which allows us to estimate bladder volume while correcting for changes in urine properties which affect the measurement. As the bladder fills with urine, the amount of current flowing between the outer electrodes increases, which enables volume approximation with correlated pressure measurements from the integrated pressure sensor on the same device. In our ongoing work, we have implanted active and sham devices in 8 animals suprapubically. All animals showed behavioral recovery after 24 hours, but reduced bladder capacity of up to 50% for 2 weeks after the implantation. This reduced capacity was not only due to displaced volume from the device, because it only displaced 1 cubic centimeter in the bladder. Animals also showed increased voiding frequency for up to 2 weeks after implantations, but then returned to normal urinary behavior. All devices were explanted after 4 weeks without evidence of urinary tract infections, heavy metal leaching, or urethral obstruction. Since you're watching this talk over the internet, it only seems appropriate to include a cat video. Here you will see the cat freely enter the litter box while wearing the data receiver, allowing us to record voiding pressures without catheters. In this example, the animal is choosing to use the litter box unencumbered after a period of natural bladder filling. Now, I know watching videos of cats peeing is a strange experience, but this highlights the promise of sensors like these, which will allow us to observe how the bladder functions during natural filling and voiding cycles. In the future, pairing this data recording with implanted neuromodulation and EMG measurement devices will enable chronic studies of how neuromodulation affects the bladder and associated neural pathways. In our previous work, we have shown that the volume sensor has modest accuracy over a range of saline concentrations at volumes in the typical feline bladder capacity. Here I am presenting examples showing bladder pressure and volume measured from conscious cats. In this first example, you can see decreases in measured volume accompanying a long sequence of voiding contractions due to bladder irritation caused by the recent implantation surgery. But after another week of recovery, natural bladder filling volume was observed, accompanied by less frequent non-voiding contractions. To conclude, this device is the first example of catheter-free bladder pressure and volume sensing in research animals. In our work, and in collaboration with others, we are now using this tool to explore the neural circuitry of the lower urinary tract. This will enable development of new neuromodulation strategies for the bladder, but also for other organs like the bowel. Thank you very much for your attention, and I hope to hear from anyone who is interested in this work.